Everyone, this is the solutions to the 2025 Extension 2 Maths HSC paper. In this video, we're going to look at the multiple choice questions. Question 1. Points A and B are negative 3, 1 and 1, 4 respectively. Which of the following is a vector equation of the line AB with parameter lambda? So we need a direction vector, which could be A, B, which is 1 take away negative 3, 4 take away 1, which is 3. And then we want the direction vector plus a point that lies on the line. So the answer is D. Question 2. There exists x, that is an integer, such that x squared is odd. Which of the following is the negation of the statement? So remember, the negation of there exists is for all. So for all x that are integers, x squared will not be odd. So let's see what we've got that might be like that. So it's not A. For all x that are integers, x squared is even. It's B. Question 3, what are the square roots of 3 minus 4i? Now you can do this by setting, x plus I, y all squared equal to 3 minus 4i and move on from there. But we can also just square these and see what we get. So let's start with A. 1 minus 2i all squared is equal to 1 take away 4i plus minus 4, which is equal to negative 3 minus 4i, so it's not A. 1 plus 2i all squared is equal to 1 plus 4i. It's not going to be this one, is it? Minus 4, so it's not B. 2 minus I all squared is equal to 4 take 4i minus 1, which is equal to 3 minus 4i. That's a possibility. Let's do the other one. Negative 2 plus I all squared is equal to negative 2 all squared is 4 minus 4i minus 1 is 3 minus 4i. Okay, the answer is C. Question 4. A particle in simple harmonic motion has speed v meters per second given by this, where x is the displacement from the origin in meters. What is the amplitude of the motion? So I'm going to take my v squared equals minus x squared plus 2x plus 8. I'm going to get rid of that negative. And now I'm going to complete the square. So negative, we've got x squared minus 2x plus 1 take away 9 is equal to negative x squared, x minus 1 all squared, take away 9, which is equal to, I'm just get rid of that, negative 9 take away x minus 1 all squared. Now this is of the form v squared is equal to n squared a squared minus x minus c all squared. And so it's 1 out the front here. So a squared is equal to 9. So A, which is the amplitude, must be 3. So the answer is B. Question 5. Consider the statement, if x squared minus 2x is greater than or equal to 0, then x is less than or equal to 0. Which of the following is the contrapositive of the statement? So remember, we're going to switch these around and negate them. So if x is greater than 0, then x squared minus 2x must be less than 0. Which one is that? That is A, isn't it? Question 6. The complex numbers z and w lie in the unit circle. So that means the moduluses of z and w is equal to 1. The modulus of z plus w is 3 halves. What is the modulus of z take w? So let's just draw a quick diagram. Because these are both 1, when I add that up there, it's going to be the diagonal of a rhombus, like that. So this is 3.5 along here. Now that's z, that's w, this is z plus w. This is what we want here, z take away w. We know that the diagonals in a rhombus meet at right angles, so this is reduced to Pythagoras' theorem. I'm going to call that x. And the diagonals also bisect one another, so half of 3/2 is 3/4. And that's 1. So x squared is equal to 1 take away 9 on 16, which is 7 on 16. And so x is equal to root 7 on 4, but we want to double it, so it's going to be root 7 on 2, which is B. Question 7. The complex number z lies on the unit circle. What is the range of arg of z minus 2i? Okay, so that means coming from here and going towards z, and z lies somewhere on here. Now we're only interested in the extremes, and that would be when this is tangent to the circle, there and there. And we want to work out this angle in here. If I draw up that radius, we know that's right angles. So that's 2 there, 1 there. So let's call this theta. Sine theta is equal to half, so that's going to be equal to pi on 6, which makes that pi on 6 as well. Now, we want, the argument is from the horizontal, and we're going below the axis, so that's negative pi on 3, because this is pi on 6. And then this one here would be negative 2 pi on 3. So our argument's going to lie between negative pi on 3 and negative 2 pi on 3, which is B. Question 8. The graph shows the velocity of a particle as a function of its displacement. Which of the following graphs best shows the acceleration of the particle as a function of its displacement? Interesting question. So we know acceleration is equal to v dv dx. So if we find the derivative of this graph and then multiply it by this graph, we'll have a graph of acceleration. Okay, so let's do the derivative. We're increasing, 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 and 0 here. Decreasing, decreasing, and 0 here. Increasing, increasing. So plus, minus, plus. We have a parabola that's concave up. All right, let's get rid of a little bit of that rubbish so we can see what's going on. We now need to multiply it by the original graph, the graph of velocity. And basically, anytime you're multiplying by 0, you get 0. So that's going to be a 0 there. It's going to be 1 here. There'll be 1 there, and 1 here, and 1 here. There are 5 zeros, which knocks out C and D. Now, this one's got 5, 3, 4, 5, and this one has 1, 2, 3, 4, 5. So what's the difference between A and B? They both start down here, end up here. Let's have a look at where the zeros are. Oh, I see. There's only 1 on the negative side. This one here's got 2 on the negative side, and also 1 at 0. So it's actually A is the answer. Question 9. The points U, V, W, and Z represent the complex numbers U, V, W, and Z respectively. It is given that V plus Z is equal to U plus W, and U plus KIZ is equal to W plus KIV. K is real and greater than 1. Which quadrilateral best describes U, V, W, Z? All right, I didn't get a lot out of this one. Let's start with this, and I'm going to rearrange it. U minus W is equal to KI, V minus Z. And just taking a generic shape, this is U, V, W, Z. These are the diagonals. So U minus W is there, and V minus Z is here. Now we know that multiplying by I means rotating by 90 degrees, so we at least need the diagonals to be at right angles. So there goes rectangle and parallelogram. But we also want the diagonals not to be equal, because in a square they are, and K is clearly greater than 1. So this is a number greater than 1, like 2 or something like that. And so the length of this diagonal will be 2 times the length of this one. So it can't be a square, it has to be a rhombus. Question 10. Which of the following gives the same curve as cos t, negative t, and sine t? Now, I'm hoping that you can see that we can immediately cross out b and c because of the t squared, because what that does is restrict the range. If we put in a positive value for t, no worries, but if we stick in a negative value for t, we're going to get the same graph as we would for the positive. So we've lost half the graph. So it's not b or c. That brings us down to 2. Now, we can see from this that we could do x is equal to cos t and z is equal to sine t. And squaring that, we get x squared plus z squared is equal to 1. But we're going to get that here and here. There's no way to differentiate. So in fact, I'm going to do something different. I'm going to look just at y and z. So looking at a, actually no, looking at this, if we've got y is equal to negative t and z is equal to sine t, then z must be equal to sine of negative y, which is negative sine y. So that's what we're looking for. Now if we look at a, we have got y is equal to 2t, z is equal to sine 2t, and so z is going to be equal to sine of y, which is a different orientation. So the spiral is going to go the opposite way. So it's not A, which makes it D. Okay, that's it. In the next video, we'll look at questions 11 to 13.